Hello, everybody, and welcome to Industrial Automation. It doesn't have to. In case you're new to the program, I'm Brandon Ellis. I'm your host and also the owner of elliTek. As we jump into the episode for today, I want to ask that you hit that follow button and subscribe button based upon the platform that you're listening on. And if you're listening specifically on Apple Podcasts and Spotify, and you enjoy what you hear today, leave us a 5-star rating and review. We sure would appreciate it. Now that we've got the marketing out of the way, I just want to say thanks for tuning in. So, let's get started. Hey guys, welcome to Industrial Automation. It doesn't have to. Hey Beth.
Hey Brandon.
There we go.
You got it.
I almost missed it.
I know.
So it's springtime, and
Yeah.
for those of you out there listening, I'm singing a little baritone today because as the vehicles have turned yellow
I know.
from all the pollen, the flowers have started coming out. It's been beautiful. Weather's warming up.
Yes.
And my sinuses are locking up as a result. So yeah, if I sound a little more like a baritone today, you're right. You don't adjust the station. So we're going to try to get through this today. But yeah, spring. So Mother's Day, belated Mother's Day.
Yes. Happy Mother's Day to all the moms out there and soon to be moms.
Yep. So did you do anything special on Mother's Day weekend with your?
I got to see my mom the Tuesday beforehand.
Oh, yeah.
So it was
So
nice. Yes.
you
We had
went
a
early.
nice visit.
Yep. So we went to see my mom as well. So
Nice.
I got to spend some time with her and see some friends. It was a good weekend. It was a nice weekend.
Yeah.
The weather that was when the weather kind of started warming up a little bit.
Yeah.
So wherever you are on this great green earth, maybe spring is there, maybe it's not. But in our part of the hemisphere or the sphere, it's becoming spring,
Yes.
and yeah. So all that comes with spring.
All the joys.
That's right.
I enjoy it, but I don't have the sinus problems that you do.
Yeah, it's not a blessing, it's a curse. So let's jump straight into today's podcast because
Okay.
remember our goal, of
Yeah.
course, is 35 to 40 minutes on our podcast. So I think we went a little beyond that last time,
okay.
but we got closer.
Yeah.
We're honing in upon it. And of course, if you're new to Industrial Automation, it doesn't have to. The podcast is primarily aimed toward folks that are in industrial automation, not necessarily in the technical and engineering part of industrial automation, but maybe in the business side, the management side. And so we're going to be talking about some of the things. So we talk about some of the technical topics, but we put that in a way that it's more of a 30,000-foot view, and also talk about how we can use that from a business standpoint to utilize that within some decisions within a manufacturing environment, both small and large. And so a lot of that is based upon what's trending, based upon what's going on, based upon what we hear from day to day from our customers and our users, and our website and social posts and comments we hear from folks and things of that nature. So this podcast today is a continuation
Yes.
from the last podcast. And so what's the title today, Beth?
All right. So today's title is Industrial Automation. It doesn't have to be Industry 4.0.
Yeah.
So there are a lot of definitions of Industry 5.0 when I was looking this up. Because remember, you said, do your research.
Yeah.
So I did.
So we are talking about the topic is Industry 5.0.
Yes.
And so it's going to be an interesting discussion today, but yeah, so you're right. There are a lot of definitions.
Yes.
A lot of people ask. I mean, this is really no different than we weren't doing the podcast then, but when the world was coming into Industry 4.0. What is this stuff? What is an Internet of Things? What the heck is a thing? And that kind of thing.
Yeah.
And so, are we coming into a new industrial revolution or are we not?
I don't know. But according to the internet, do
Yep.
you want to hear what they have to say?
Yeah, go ahead.
So according to the internet, some say that Industry 5.0 combines human creative and critical thinking with the speed and skill of automation. And the EU predicts Industry 5.0 will prioritize the well-being of the worker.
Hang on a second, I process that. Prioritize the well-being of the worker.
There's also other people out there that say it's to go towards a wasteless world. But we're talking manufacturing, so...
Wasteless meaning use every part.
Yeah.
Yeah.
Which is a great idea. I think it's a fantastic idea. But for our purposes today, we need to talk about.
Well, that's an adage as old as the Indians, right?
Yeah.
That was something that Native Americans always prided themselves upon, is they used every part of the animal.
Exactly.
And so I assume that's what we're talking about with a wasteless world. But certainly efficiencies could come from Industry 5.0.
Yeah, but there's some facts.
Okay, let's get to the
All
facts.
right, so the facts. Industry 5.0 will support humans, not replace them with robots. Yeah, even Elon Musk tweeted that humans are underrated.
You've heard us talk about the wiggle jiggle.
Yeah.
So it's hard to take the human element out of things.
It is. Industry 5.0 is about finding the balance of efficiency and productivity.
Mm-hmm.
And then finally, it's unavoidable.
It's kind of like in Star Trek Next Generation, the Borg.
Oh, yeah, right.
Resistance is futile.
That's right. So this is a lot of stuff, a lot of different viewpoints, and we still can't settle on what Industry 4.0 is. But what's Brandon's definition?
Well, I think we go back to, let's go way back.
Okay.
And then I'll come up a little bit. That's still back. So let's just pretend for a second about the first time a human being, a caveman, witnessed fire. The very first time. I mean, if you can put yourself there, think about, there is something, there was a lightning strike, struck a tree, and suddenly there's this orangish yellow glowy thing in front of you. And so the immediate properties of fire, that you can tell, it gives off light. So if it was dark, suddenly it's not dark anymore. And you could probably assess pretty quickly that it's hot.
Maybe.
But really outside, and then it's just amazement at that point. There's this thing that I've never seen before. And now look at what we use fire for.
Oh, it's a lot of things.
We use it for cooking. We use it for producing things out of the ground that don't come out of the ground that way. So steels, metals, various types of salts and things of that nature. So all those things evolved. We realized what we could use this tool for. And from that, all kinds of things happened. So I don't know if that counts. I mean, it doesn't count as Industry 0.
It might be.
But, to be able to see something the first time and all of a sudden say, wow, that's fire. We can change the properties of metal with that before you even knew what metal was. Or maybe you did know, but you didn't know what the effects of fire on metal are. Mm-hmm. So now we fast forward to Industry 1.0, steam and water production. So water wheels, the steam engine, things of that nature. Actually, 2.0 is when we began to put those things together. That was basically the Henry Ford world of interchangeable parts and getting machines to work together and create mass production. Industry 3.0, the advent of the programmable logic controller and using digital devices to control things. Or even, basically wiring up relays and timers and that kind of stuff is still the very, very onset of Industry 3.0. And Industry 4.0 was when those devices began to give way to intelligence. And now we're talking about Industry 5.0. So Industry 4.0 certainly has a lot of definitions, but we understand a lot more about it now because we have been able to evolve through it, just like evolving from the first time man witnessed fire to being able to utilize fire to do stuff from cooking to actually creating things. So Industry 4.0 gives us the building blocks. The best analogy I have is Industry 5.0 will be the result of the blocks from all the other industries.
Do you have an example?
So the best example that I can think of right now is Mr. Steve Jobs, who most credit with the inventor of the smartphone. Now, let's think about that. And if you don't know the story, it's a very interesting story. But Steve Jobs, before that, had invented the digital music player. I don't know if he invented the digital camera, but we had digital cameras. And he did not invent the cellular phone, but we had cell phones. We had those three things. All Steve Jobs did was said, I'm tired of wearing my digital camera around my neck in the little bag and my phone on one side of my belt and my MP3 player or digital player, music player on the other side of my belt. What if I could just put all those together? And so when he put all three of those together, he created the first smartphone. But he didn't invent the pieces. The pieces were already invented. They evolved. He evolved us into a new place. And honestly, there's no question that smartphones have affected, in the last decade especially, but maybe 2 decades, have affected the human race from top to bottom. I was walking through Lowe's department store. They have all their spring outdoor furniture set up inside the store, but set up all nice. And this little lady was taking a break, had sitting there on one of the cushioned couches, just taking a rest. She was probably in her 80s, and she had her smartphone going through her smartphone. I turned the corner, and there's a husband and wife with their young teenage daughter following them. They're shopping. She wishes she was somewhere else. Yeah. And she's just sitting there walking, and she's on that cell phone. So that smartphone has affected everyone. Mm-hmm. And there are some out there that still have the old flip phones and that kind of stuff. So be it. But you cannot deny, from 3 or 4 years old all the way up to 100 years old or more, it has affected and can be utilized by all of that. And so that didn't happen at first. I don't think when Steve Jobs created the first iPhone, that was a camera, a music player, and a cell phone, that he may have kind of thought maybe people would use this and it would have this effect. But I don't think so. I don't think he knew.
Yeah, and then it's just built upon, all the stuff is built upon that, hasn't it?
So he didn't invent anything. He just combined things. Uh-huh. But in combining things, he invented something that changed the world.
Yeah.
So, I was having a conversation with a customer there in the nuclear industry, and so we were talking about nuclear power plants. And so a nuclear reactor just basically takes radioactive. Now, I'm not a nuclear engineer, but it takes materials, creates a reaction. That reaction creates heat. They take heat, with it they heat water. Water turns to steam, and with steam they turn a turbine, and a turbine creates electricity. Well, that's Industry 1.0.
With the steam?
The steam, the water, that's 1.0, combined in with whatever industry, nuclear fission, fusion, whatever we're doing there, it was invented. But my point being, we're still using the building blocks of Industry 1.0. You take out the steam turbine, you're not making electricity, you're just making heat. If your goal is to make heat, winner. But if your goal is to make energy from that process, it must have water, it must convert that to steam, and it must turn something that's connected to a generator that moves magnets across coils of wire and creates electricity. We do the same thing here in the East Tennessee Valley with hydroelectric. Mm-hmm. So hydro and all those kind of things are still, they're newer concepts, but they're still using Industry 1.0 concepts. Industry 5.0 is going to use all of those concepts coming up because they're already in use. So Industry 4.0 was just taking those digitally controlled concepts and processes and turning them into a smart communications means. The slowest thing that we have, and Elon Musk said this, the bottleneck with any kind of digital AI, artificial intelligence type system are your thumbs. and that's because we're on smartphones usually with our thumbs. That's how most people type. And it's slow. Even if you're speaking, it's slow. So,
well, compared to machine-to-machine
communications. And so that's the bottleneck. So we have taken in Industry 4.0 for the benefit of humans, and all this is for the benefit of humans because if it's not benefiting humans, what's it benefiting? We've taken all these processes that can give us data and define our processes and help us understand our processes more as far as what's really going on. I think as we come into Industry 5.0, it's more about taking that data, those means of acquiring data, and beginning to build it into algorithms that help make decisions. One of the things that's going on right now, why do we have a labor shortage? One of the large reasons is because a lot of the very experienced baby boomer generation has entered retirement, has exited the workforce, and with them, all of that experience. Yeah. And so one of the big pushes with artificial intelligence is to try to create an algorithm, a machine learning algorithm that will mature just like from a child to a youth to an adult to an older adult and gain wisdom. And then we bottle that into an app, punch in a couple of the basic things that we're seeing or hold it up so it can see the machine or hear the machine or whatever, and it pops out to say, just like the baby boomer would have said,
do the wiggle jiggle.
You need to fix this. You need to check that. You got a problem under the hood here. You need to go up top and change that. Try to get it to give us that baby boomer knowledge, and then we continue to build on it and build on it and build on it. And so that is the infancy of artificial intelligence that we're in right now, is trying to get computers to be able to think like humans and adapt and learn like humans.
So that's where the human creative and critical thinking goes with the speed and skill of automation.
Right. And what are the benefits we get from that? You've got those.
Yes. In order to yes. So what are the benefits? Do you want to go through the benefits?
Well, yeah. So
cost savings.
Right. Cost savings. You've got predictive maintenance here, and we can talk about each one of these. Creative customization that's in demand by customers, and green solutions, and efficiency and productivity. But all that is required in order for someone to remain competitive.
Yeah.
So we've talked about with Industry 4.0 and industrial IoT systems. So here's your quiz. What's the number one reason to implement an IoT system in manufacturing?
If I don't know this, then it would be a travesty.
Yeah, I hope I remember which one's the...
It's to... Oh, there we go. It's to make educated business decisions.
That's it. So that's why you have an IoT system. An Industry 4.0 type system is to make educated business, to benefit the human, the managers, the management that's making the decisions. Industry 5.0, sometimes with Industry 4.0, we sit there and we look at it and we look at it and we look at it and we look at this graph and we look at this pie chart and we look at this bar chart and we're like, I'm not sure what would change this. We see the problem, but how do we get to a solution? Because if we get to a solution, we could get cost savings, we could get predictive maintenance, we could get creative customization, green solutions, efficiency, all these things. That's what we're after. Sometimes you look at a graph or overlay a couple of graphs. Sometimes you have to look at 2 sets of data, 3 sets of data, and it's just like, boom, it just pops out, right? Just like the Orphan Annie decoder ring, boom, the secret message pops out, and it's easy. We need to stop that. We need to do this instead. But sometimes you need that 35, 40-year experience. We need artificial intelligence. But do you want to just turn your line over to an app and say, I don't know if it'll work or not? It could blow up the entire plant, right? Yeah. So we've got to start being able to put that in. That's where I think we're leading into Industry 5.0, right?
Yeah.
So do you
want to go through the concerns?
Well, before we get to the concerns, I kind of blew through those savings. So let's talk a little bit about each one of them. So cost savings, and if you don't think this is important, I guess that's okay, but hit us with a comment as to why, because we think each one of these should be equally important to people in manufacturing. So if you're a production manager, plant president, whatever, CEO, I want to know why you don't think this is important for your plant. But cost savings, everybody wants to have a cost savings, especially now. Inflation's through the roof. Costs are going up. Cost savings, more efficient operations using the least amount of resources to maximize profits. That's your definition on our outline.
Yep.
It's accurate. Makes sense? Cost savings. We want to reduce cost. Predictive maintenance. Downtime equals cost.
Yeah.
So if we can predict that, we can now be proactive instead of reactive. Reactive always costs more. Mm-hmm. What else are we going through into this day and time? We're going through a global supply chain crisis. And so part of that's because of semiconductors, part of it's because of resin shortages, part of it's because of labor shortages. But if you have a machine go down right now, you may not get that machine up and going for months.
Yeah.
If you have to have this, if you don't have a specific thing on the shelf, well, it's not cost effective to create an exact replication of every part and put it on the shelf for a single machine or multiple machines. So predictive maintenance using things like smart sensors. Again, Industry 4.0. If it's smart, it's Industry 4.0 stuff.
So Industry 5.0 is building off of...
Is building on that,
okay.
Yeah. And so some might say, well, that's like an Industry 4.1.
Oh.
But...
they don't do points.
They don't do points. And an industrial revolution, that's when something happens that really changes the game. But it has to give way to another industrial revolution. It will, otherwise it'll die, right? And so some could say, for example, that the phonographic recording was a game changer for a lot of folks. But it died. Why? Because we created cassette players, and then we created... CDs, compact disc, and now we've got streaming audio and all this kind of thing. Now they're going back to it, because it's kind of a faddish kind of thing. But the music industry changed as a result of it. It's not about selling records anymore. It's about downloads and all these kind of things. And so the whole music industry changed because of it. So an industrial revolution has to give way to another industrial revolution. Or it dies, in my opinion. And so, to run through, so predictive maintenance, the smart sensors, all those things. Yeah, you're right. They're building blocks. When Industry 4.0 was starting, so I got into what I call Industry 4.0. I was in the data side of things. Remember, if you haven't heard my story, this is it in 5 seconds, maybe. I was in. I was in the world of trying to get on the OT, operational technology, plant floor, manufacturing floor world. I was getting dissimilar controllers to talk to each other. So at the time, and still sometime today, for some manufacturers, a robot controller would not talk to a CNC controller easily. A CNC controller and robot controller would not talk to a PLC, and so on and so forth. And certainly they wouldn't talk to a PC-based system very easily. And so I began to get into that. I began to get into SCADA systems and middleware-based systems and things of that nature. And it was just, it worked, but there was a philosophical difference because we were having to use PC-based solutions and on an operational technology world, and there was a philosophical difference between IT, who owned the PC, and OT, who owned, I guess, the software or needed the software, and how they coexisted. And so that's why we invented the Data Commander. But the point being that being able to, when I started that, it was around 2011, that I saw this whole data management communications, the making the things talk was 2009. 2011 was seeing that this machine needs to talk with what's upstairs in the enterprise, and not just in this OT world. We were going to have to start bridging the gap to IT. And that was about 2011 in my career. And then, of course, it was 2013-14 that the Data Commander came to be. So, which bridges that gap. And so I remember having many conversations with many colleagues, older than me, younger than me, mentors, some, people that I was mentoring, those kind of things. And having a lot of, over dinner conversations about all the marketing hoopla about Industry 4.0 and how it was going to have all this stuff communicating and, what a thing is and all this kind of stuff. And we were thinking, we've been doing this for a long time already. We've had remote I/O systems. We've had remote, DCS systems with remote devices bringing information back and reading that back. And we've been doing this on the OT side for a long time. But what happened was those sensors that we were talking to, we were not talking really to. We were just reading statuses. So off or on, those kind of things. And so what we've seen in Industry 4.0 is we've seen those sensors, those devices, those things become more intelligent things so that we can have a conversation with them. So it may be just a distance measuring laser sensor, but instead of having to go there to the sensor and punch buttons and say, okay, this is the thresholds. And so if the distance goes, below this, or temperature or flow or whatever, turn on. And if it gets out of that window, turn off. Now we can have a conversation and even tell it from part to part to part, change that. Change what your credentials are, or your high highs and your low lows, all your parameters. Change your parameterization for this part from the part before. It's a smarter communication. That's Industry 4.0. That's some of the stuff that came as a result of Industry 4.0. So now robots, CNC machines, all the stuff that I was dealing with in 2009 because it wouldn't talk, now they talk. And so those are the benefits and the building blocks of Industry 4.0. But now that they're all talking and all of them are chatty Cathy, what are we going to do with it? We can pull it back in and we can get our graphs and things of that nature. And so predictive maintenance, we can watch what's going on. If we see something changing, see a trend, then we can apply some logic, some math, and say, okay, we think that this machine, this bearing, this gearbox, whatever, this pump is nearing its end of life. And so we're going to predict that, schedule the downtime so we're ready for it, and we're not reactive. We're going to go ahead and get the new pump on order that is 4 months. This thing we think it'll make it 6 months, so we're going to go ahead and order the 4-month pump and prepare to do a teardown before it breaks.
Yeah.
and go from there. And so those are cost savings. That's how we can benefit from this. Green solutions by producing and managing minimal waste so we get a better handle on our stuff. So scrap has always been a big deal. We want to reduce scrap because scrap's expensive to get rid of. It's not good for the earth a lot of times.
Well, aren't there companies buying scrap depending on what the scrap is?
Yeah.
So,
and to some extent, you are getting to that wasteless in the wood and pulp industry. Well, even better in the hardwood flooring and cabinet making and that type of stuff. A lot of that industry,
all that pressed wood,
all that kind of stuff, reusing it all. I've been in places where just the sawdust, they collect the sawdust and then they'll blow it into a furnace and burn it.
Oh, my grandmother used to save the sawdust so she could do her woodwork and fill in holes with it.
Yeah. But at the factories, they'll pull
burn it.
They'll burn it. What happens when you burn it? You create heat. What can you do with heat?
Steam stuff.
You can
create energy.
you can create steam. That steam can turn a turbine, and they generate their own. So they regenerate a lot of their own.
So smart.
Power, and so they're using it all. I remember seeing that the first time when I was in college. That was back in the 1900s. And so
it sounds so long ago.
Yeah. And so a lot of these are not new concepts, but
they're applying new technology or combining technologies.
Right.
Okay.
Because sometimes reducing your scrap is going to require more precision, more than a human can react to fast enough. So if we can get machines reading this stuff back and then adjusting themselves, now all of a sudden we're moving into, I believe, the onset of Industry 5.0, the next industrial revolution, where suddenly factories control themselves while humans benefit from it.
So what are the concerns?
There's always concerns. The largest concern is that anything excessive automation, stuff like that we become totally reliant upon it fails. And then what happens?
You're worse off than you were before.
Yeah, maybe. I think that's just like we've talked about cybersecurity in past episodes and things like that. Everything comes down to a risk analysis. Mm-hmm. if your machines are making safety pins or paper clips, it might hurt your bottom line as far as not making the truck and sales, but it's not going to. I don't think it's going to affect the world if there's a paperclip shortage, because
we still have staples.
Yeah, but if it's a nuclear reactor, you need to have redundant systems. You need to be able to have failover type prevention. So it really comes down to what you're doing. Not everything, even IoT. So in automotive, traceability is huge. In medical, traceability is huge, and that's where the IOTA does it. Just shines, is because it handles workflow management. It greatly allows customers to greatly reduce their what we call defect flow out, and so it'll allow a customer, or a company, if you're able to trace your parts, which means they've got to be marked QR something, but RFID, something like that. But if they can be followed through the processes, and then there's quality checks within those processes, then we can tell if this particular part failed a quality check upstream, take it out of the process, out of the queue, or rework it and reintroduce it.
Okay.
And by doing that, you don't get to the very end, and you've not expended all the materials, all the energy, all the labor, and all the cost associated with making a part that you knew was going to be bad upstream. And so a lot of those types of things certainly come into the utilization of Industry 4.0. Having a machine do that and automate that, certainly there's a lot of systems out there where if it misses the quality check and it's a fully automated process, it just rejects the part. But you don't want to just throw that away. No. You want to try to utilize it, because that you have some cost in that already. And so Industry 5.0, having a machine communicate something to a human and have that human try to surmise the solution or the adjustment that needs to take place in order to make that, whatever they're seeing, better. Whether it's cost savings, whether it's reduced scrap, whether it's predictive maintenance, and efficiency. We haven't talked about efficiency, but the last one is the green solutions, minimizing waste and scrap. But efficiency and productivity for humans, it's to make things more efficient. But if a human's having to do something, to tweak something, to twist a knob, tighten this, or write a program, or tweak a value inside of a PLC program or whatever to try to improve it, that's not efficient.
No.
Industry 5.0 in my mind, or maybe this is 6.0, and Industry 5.0 is going to be getting us to that, is when we get rid of those inefficiencies. I don't prefer it being implanting a chip in my brain so I can have the machine talk to me just like it talks to other machines. That sounds invasive.
A little bit.
But I do think we develop artificial intelligence and machine learning algorithms to the point that machines can control and make decisions for other machines and have influence and have that conversation. No different than if you were standing at one end of the line running your process and I'm at the downstream, and I say, the part's coming in too quick, you need to slow down, and you make adjustments to slow down. The machine's doing that so that humans don't have to get involved.
Yeah.
But there is scariness about that. So what do we do to solve that?
Yeah.
Right?
What do we do?
So this is where I think Industry 5.0, at least as we move into it, this is what we're going to see.
Okay.
We call that digital twin.
Ah.
So digital twin is a I don't know, maybe that's a new concept or new word or phrase for folks. We've talked about digital twinning for a while. It kind of was a thing before it had a name.
Okay.
So we use that a lot in 3D solid modeling. So there are a lot of 3D solid modeling CAD softwares out there that you can design an entire plant, an entire factory, everything in 3D space. We can even apply limitations or restrictions to things to say, to emulate how the mechanics will work. So if a robot, for example, can only move in certain ways based upon all the joints in the configuration of the robot. And so if you get it on a computer, if you take away those limits, joints can just spin on top of they can pass through each other, all this kind of stuff. So you need to emulate what's real, what's realistic. We've been doing that with robotic simulation for quite a number of years. A lot of robot manufacturers, two that come to mind we represent, Fanuc and Motoman, have simulation environments. And so these simulation environments will allow you to put in a 3D solid modeled type environment and then drop the robot in and actually begin to program it in this simulated world.
Nice.
You can then take other simulation programs, so PLC simulators, HMI simulators, other things that we would use on the line in OT.
Put them all together?
And have them all begin to talk to share information together. So as the PLC simulator is simulating what the PLC would see, it's sharing information with the robot, and the robot's sharing information with it. And now you can begin to digitally twin your process. It's like the holodeck from Star Trek.
Okay.
So we create this virtual or digital representation of our process. So we've kind of already been able to do that.
Is that like augmented reality?
Well, augmented reality is for humans.
Oh,
that's where we put on the glasses or just like your smartphone. So if you're doing Instagram or something like that, and you put on a filter that changes your head to a kitty cat or an alien or something like that, but the rest of you still you're in the room. That's augmented reality. Virtual reality is when nothing's real.
Yeah.
It's all a cartoon, right? But in our case...
So digital twin isn't a virtual?
It's not. It can be. It can utilize augmented reality to put you into the situation as a human.
Okay.
But the whole idea for digital twin, or the limitation, has been we have these means of digitizing and simulating, but your simulation is only as good as your simulated environment and simulated things.
So when you're putting all these different simulation things together, do they talk to each other?
They can talk to each other, yes. But if I'm doing a simulated input here from the PLC side, saying this came on, this sensor came on, or you can't even, sometimes you can't really emulate external things like the smart sensors.
Oh, yeah.
So there's limitations. You can only get 60, 70% close to what the real thing would be if you're trying to see if this will work or try out scenarios and things of that nature. Industry 5.0, in my opinion, is taking the digital environment to digitally twin your very real, very out there on the machine floor running line. And then in a real-time fashion, take sensor data, smart sensor data that's going in that line, as well as the PLC code and everything that's running in that line, and having that come into the simulation. So you're not having to simulate your simulation.
Okay.
And so we begin to pull that into this digital environment, and now we can tweak with it, just like the holodeck. And if the line explodes, it's not a big deal. The best analogy I've got, because I fly airplanes, is there in flying airplanes there's been huge conversations on what we call the impossible turn. The impossible turn is you've taken off, you're climbing out from the airport, you've just gotten off the ground, and you've established a climb, and you lose your engine.
Oh.
Can you turn the airplane around 360 degrees and come back and land at the airport, or can you not?
Oh.
And so there's been a lot of people talk about that in different models and all this kind of thing. It's kind of a fun pilot kind of debate that we have. In our case, though, it's not one you want to try.
No, I would simulate it first.
If you do try it, you're taking a chance, but you don't want to actually really turn your engine off. You want to feather it back a little bit, but have it still running. You want to be able to make sure you can get that engine back on just in case you don't make it. And then also, it's just not a good thing to do because you're really close to the ground, and when the airplane meets the ground, bad things happen unless you mean for it to. But in a flight simulation environment where we can simulate environmental conditions and things of that nature, now if we don't make it, we're okay. We just try it differently. We simulate things through the input of real devices. The control yoke, the throttle is stuff that and the rudder pedals are things that the human can be inputting as they're seeing this virtual environment. So it's almost virtual reality, augmented reality, but we're able to go through those and see if we think, if you make it 1 time out of 10, then the chances are the answer is no. You shouldn't try that maneuver. There's probably safer maneuvers in that situation. So in industrial manufacturing, same kind of thing. That's what I believe we're moving toward in the onset of Industry 5.0. I believe the end game of Industry 5.0 is that we finally feel good enough about the algorithms that we've built based upon this digital twinning process that we will be able to say, okay, now let's implement. And in the real world, we implement those things and let the machine start tweaking the other machines back and forth, having this conversation. And suddenly, we're not really replacing humans. We're just accomplishing all of these things: cost savings, predictive maintenance, creative customization, green solutions, and energy efficiency and productivity at record pace and highly efficiently. Because me hollering to you, it's too fast, slow down, is already inefficient.
Yeah.
You having heard that, decide how you can slow it down is inefficient. If we can do that in microseconds or milliseconds, then suddenly it brings out something completely new. And from that, you will have your next industrial revolution. So I think, and again, my crystal ball is just as muddy the water is just as muddy as everybody else's, but I feel like the Industry 4.0 is still maturing. It's establishing the building blocks of intelligence that we need from the edge devices, the things, the sensors and things of that nature, up through the PLCs and the processors and the robot controllers, and even up to the data management systems and that kind of thing. But those building blocks, just like Industry 1.0 supports nuclear power generation, those building blocks will be what creates the awe-inspiring innovation of Industry 5.0.
Awesome.
So it's a different point of view. It's something we're already into. So we should do a podcast at another time about companies that are doing this.
Oh, yeah.
Now, I'm not saying that's our next podcast, but it's probably in the near future.
It'll be in the Rolodex,
Yeah.
how's that? If you know what a Rolodex is.
So all kinds of stuff. And this is not quite Marvel Comics. I don't know if we're ready to put a iron suit on that's got, some type of ion-based jets in the feet and the hands and fly around. But who knows? Maybe an Iron Man suit's right around the corner. But Industry 5.0 is certainly something I think we're on the cusp of.
All right.
So industrial automation, it doesn't have to be Industry 4.0.
That's right. Thank you, Brandon. I appreciate your time.
All right, guys. Thanks for listening. And remember, give us those ratings if you love it. Give us comments. We want to see the feedback. And if you want to see what we look like and not just my baritone voice, check us out on our YouTube channel or LinkedIn.
That's right.
So, all right, Beth, let's call it.
All right. Thanks, Brandon.
Have a good day.
See y'all.
See you guys. Hey guys, thanks for checking out today's episode of Industrial Automation It Doesn't Have To. I hope you enjoyed it. If so, make sure you give us a rating that's pretty doggone high, and do that everywhere you listen, including Spotify and Apple Podcasts. We'd really appreciate it. Also, don't forget about our website. That's www.ellitek.com. That's ELLITEK.com. If you want to reach out to us there, you can fill out our contact form. We'd appreciate it. Also, you can email us at info@ellitek.com. And certainly for those of you that still like to dial the phone, give us a call, 865-409-1555. We'd love to hear from you.